Welcome to the introduction to biological macromolecules. This is covered in Unit 1, Section 1.3 of AP Biology or College Biology. Please note the disclaimer listed below that AP Biology is a registered trademark of College Board and is not involved in the development of the products listed. Okay, let's get started. Now, when you're reviewing anything in the Unit 1 section, please note some of this material might be a review, and that's okay. We're covering the information as it relates to biology. If you feel that you are strong in these topics, feel free to fast forward to the questions at the very end to see and test your knowledge. Let's get started. We know that there are chemical bonds between elements that form some sort of compound, and usually they're bonded by electrons. So electrons will be connected together. Those electrons are seen, for example, if you take a look at oxygen, you might have those little dots. Well, those dots can be shared or transferred, and that's designated by a line. So when we talk about chemical bonds, we're talking about the elements being connected, and in pictures that's designated by various lines seen here. So if you have one line, that means one bond. If you have two lines, that means two bonds. If you have three lines, that means three lines that are three bonds. So as you get more and more bonds, the tighter it's held together. So just be aware of that notation. Okay, for AP Biology or College Biology, you are expected to know the types of bonds that exist, which include ionic, covalent, metallic, and hydrogen. Hydrogen bonds have been covered previously in the unit. And just as a reminder, hydrogen bonds are bonds with hydrogen alongside three specific elements, F, O, and N. So if you see hydrogen attached to a fluorine, or hydrogen attached to an oxygen, or hydrogen attached to a nitrogen, we're talking about hydrogen bonds, which can be found in water. Please note metallic bonds are electrons that move throughout the metal atom, and they're very conductive and malleable. Think of iron or copper. And then the most popular types of bonds to distinguish are the differences between ionic and covalent. Covalent, I think of as sharing. So I think of the word share and then covalent as having the same sound. So what I mean by that is covalent starts with the letter C and share starts with the letter S, and they both make that noise. So that's the way that I remember covalent sharing. Ionic bonds are transferring, and transferring meaning that they donate an electron. So I think of the word transfer alongside with the word ionic. And an example of this is salt. So feel free to take a screenshot of this page. We'll go into more detail in just a second about how to tell the difference more in detail. So this is how we would tell more in detail with a periodic table. I understand for AP Biology, you're not often given a periodic table, but this is just a relative way to understand this topic. So the term electronegativity is important, which basically says that you can become more negative as you go up the periodic table and to the right. So the left side of the periodic table is more than likely positive, and on the right side of the table is going to be more negative. So I have a little plus sign here and a minus sign there to help you better understand the idea electronegativity as going diagonally to get more negative. It becomes more negative. So this is important to note. I also want to highlight that if you go in the center here, you see the elements like iron or copper, and that's because those are those metallic based elements, and that's why they're more likely to formulate a metallic bond. So if you were to be given a periodic table, you can make that distinction based on what a metallic bond is. With hydrogen bonds, you note that H can easily attach with NOF or fun, F-O-N, and that's stuck together on the same region of the periodic table. Hydrogen is an interesting element. I just want you to keep that in mind for future topics related to biology, as it sort of finagles between the left and the right for various reasons. Okay, so let's talk about the difference between ionic and covalent. If you remember, ionic means transfer of electrons and covalent means share. So if we take a look at something like salt, which is considered an ionic bond, if you take a look at the element Na, and if you take a look at the element of Cl, they're on two opposite sides of the periodic table, which means that they have unlike charges. So because they have unlike charges, they're more than likely going to form an ionic bond. In difference, a covalent bond, something like, let's say, CO2 or carbon dioxide, if you see carbon here and you see oxygen here, they're on the same side of the periodic table. They share a charge. Remember, share covalent. So they're going to be more than likely formulating a covalent bond. So once again, if you see elements and they're on the same side of the periodic table, more than likely they're going to form a covalent bond. I want you to make note of the word more than likely, because if you take a look at water, which is a very popular covalent bond, in terms of AP biology, you see hydrogen is on the left side and then oxygen is on the right side. And you might be like, didn't we just say they have to be on the same side of the periodic table? That's where the exception comes in. Hydrogen can waver between both sides. So if you're trying to distinguish between ionic and covalent bonds, make sure to note that hydrogen is the exception to making that distinction. So once again, ionic is going to be transfer of electrons, and their elements more than likely would be on opposite sides of the periodic table, which means that they have unlike charges. If it's a covalent bond, they're going to have very similar charges and more than likely are going to be on the same side of the periodic table, with the exception of hydrogen.
Okay, so now we're going to review the difference between polymers and monomers. Before we begin, in a lot of biological terms or a lot of science terms, you're going to find root words or ending words that's going to help you piece together the meaning of the actual word. So feel free to take a look at the picture here with this beautiful table. And you see the first word here, which is a monomer, and you see the root mono. Mono means one. So a monomer is one molecule, a simple molecule. And the unique thing about this one molecule is it has the ability to bind to other molecules. And those other molecules is something that they call polymers. Poly meaning many. So a polymer is built up of monomers. So if you have a ton of monomers that build together, they form a polymer. So say we have monomer 1, which attaches to monomer 2, which attaches to monomer 3. That eventually forms a really large shape, which is your polymer. Now, when it comes to macromolecules, we're going to talk about several different polymers, specifically 4 different types of polymers, which happens to be 4 different type of macromolecules. That is the overall arching theme of Unit 1. So for now, you just need to know monomers are the building block of polymers, and they build up polymers, and monomers means one molecule and polymers means many, and they are composed of a lot of polymers. Okay, so let's take a look at the examples here. So this is just a preview of what's to come down the line. You see here a picture here, and you might notice this functional group, NH2, which is either aminide or amide, I should say, or you can say it could be anything with AMIN, amide, amine. all of those functional groups have nitrogen in them. And that's your little hint to know that that's going to be an amino acid if it is just one molecule. And that happens to be the case here. So this is a picture of an amino acid, which we in biology now know. If we see the nitrogen, that's going to let us know, hey, that is an amino acid. And guess what? If we have a bunch of these attached to each other, they're going to build proteins. So proteins are one of the macromolecules we're going to talk about later on. And if you think about protein, they're going to be something that you might see in a bodybuilder. I like to think of someone that takes like whey protein, for example. They're going to be going ahead and working on their fitness, so they have a lot of protein. So that's just a way to remember the difference between monomers and polymers and how we're going to review those four different types of macromolecules, which are composed of four different types of polymers, which have monomers in them. We're going to talk about covalent bonds. When we talk about covalent bonds, we're talking about the stability of that covalent bond. Remember, we're talking about sharing of electrons. Covalent bonds share electrons. And because of this, there's going to be this tug of war that is involved in the process. You might want to think of it as this small guy on one side and then three other guys on the other side, and they're constantly pulling and tugging at each other in this tug of war game to ensure that it's balanced. And that's how the compounds are when it comes to a covalent bond. They're constantly pulling and pushing to try to find a balance that's stable for the molecule itself. So whenever I think of polarity, I think of this tug of war that occurs. Now, you can have different kinds of polarity. You can have nonpolar covalent and polar covalent. If something is nonpolar covalent, that's when the electrons are shared equally. So it really means that it's balanced all around. If we take a look at, for example, this molecule here, which is Bl3, and if you remember, we talked about electronegativity. The thing is, chlorine on all sides is going to be balancing each other out. There is no lone pair here, and it forms a shape that they're equally tugging, I should say, on all sides. So they cancel each other out, which means that it's going to be nonpolar. Now, polar covalent causes this really uneasy tugging because it's unequal sharing of electrons. A perfect example, if you get any question related to this, more than likely the answer is going to be something associated with water, because water is one of the more popular molecules that you're expected to know for biology. And you have these lone pairs here. You have these pair of electrons that are there, and they're not really attached to any hydrogen. If you remember, you have H2O, and H2O has two hydrogens attached to oxygen. And yes, they're going to be pulling in this tug of war. And you might be thinking, well, isn't it going to be a line? No, because even though you have an oxygen and two hydrogens on either side in that shape, you have these lone pairs that exist that sort of tends to make it bent. And because it's bent, it's kind of uneven. And because it's uneven, the polarity tends to be unequal. And that's what's going to be polar covalent. So that's a way to think about nonpolar covalent versus polar covalent. For AP biology or college biology, you're expected to know the difference between intramolecular and intermolecular bonds. Please note that the word bonds can be interchanged with the word forces. And so in textbooks, you could see either bonds or forces, or in exams or in future classes. So please note that it could be either or, and keep that in the back of your mind when reviewing this topic. Okay, let's talk about intra versus intermolecular so we can understand the difference between the two. So for intramolecular bonds, we're talking about within a molecule. For example, if you have something like hydrochloric acid,
We know that the hydrogen is attached to the chlorine, and we know that there's a connection between the two. There's essentially a bond between the two. The relationship that we're looking at is intramolecular that we're looking at, or we're looking at the intramolecular force or bond, in that case, between the relationship between hydrogen and chlorine. Now, if we're looking at intermolecular bonds, let's say that we're looking at hydrochloric acid again, but we're looking at the relationship between hydrochloric acid, which is one molecule, and another molecule of hydrochloric acid to really see how they connect. So maybe this hydrogen here connects to this chlorine. And so we're looking at the relationship between the molecules that are molecule one and molecule two. Now, in real life, it's not just going to be two molecules, it will be many, many molecules that are connected, but we're looking at the connections or bonds between those molecules itself and not within the molecule itself. Now, it's hard when you're on a test or an exam to try to remember the two, and it can be confusing. So I'm going to come up with a way to remember it and share it with you. So hopefully that helps. So in your house, you have access to the internet. And if someone in your house is working for a company, they might have access to the company's intranet. You might not be familiar with intranet. So intranet could be within a company or organization. They might have a login access that you can look at company information, and that's shared with different employees. So intranet means that you have one molecule, which we'll call company C, and we're looking at the relationship within this molecule amongst the employees. So that's intranet. Now, if you have the internet, you're looking at bonds between molecules. So say you're at home and you're logging into your internet, which is A, and then you have a neighbor who also has the internet as well, but they might have their own internet access that might be different. So they have their own internet. So you're looking at yourself as one molecule and your neighbor as another molecule. And while you both have access to the internet, you're looking at the relationship between the two. Sometimes you can think of a electric copper wire that might be seated in the ground, and you have access to one internet, but your neighbor also has access to the other internet that is with the same copper wire, but you are very separate but together in that sense. You're comparing the relationship between the two, whereas intranet is the same exact sharing of the same exact company. So that's a way to remember the difference between intramolecular bonds and intermolecular bonds if that gets confusing.
Let's go over the difference between dehydration synthesis and hydrolysis. Firstly, I want to go over the term dehydration. If you think of someone that's dehydrated, that means that they have a loss of water or they don't have enough water due to the release of water. So that is part of the definition here. There is a release of water in the reaction overall. In opposite, hydrolysis, you could see the term hydro or water is coming in. So there's an addition of water. Overall, the purpose of the reaction for dehydration synthesis is to go ahead and form a polymer. And the way that polymer is formed is by taking a hydroxyl or a hydroxyl here and here, I should say, an OH and an OH on both monomers and combining those to then release water, leaving behind one oxygen. Remember, there are two hydrogens here and there are two oxygens here. So H2O has two hydrogens, but one oxygen. So one oxygen is left over, and that oxygen is utilized to combine the monomers together to then formulate a polymer. This takes a lot of work, so it does require energy. In opposite, hydrolysis is the process of breaking down the polymer. So overall, you have this polymer that has oxygen already in it, and water is coming in to then separate the polymer into separate monomers and going in the opposite format to then have the hydroxyls attached to both separate monomers. Now, this requires a release in energy, and that is different than dehydration synthesis, which requires energy.
Let's take a moment to answer some questions to see if we are able to understand the concept that we learned. Take a moment and read the following question. Make sure to pause this video while you're reading the question and then unpause once you've completed the question. Okay, great. Now that you've returned back to your question, let's take a look at the answer choices to see or understand what is the potential correct answer. So the first thing I want to point out with this question is the term incorrect. Incorrect is a common type of question that you will get for any sort of science-based standardized test, especially for AP biology. And that's because your mind tends to gear towards understanding the correct response. So we're looking for one incorrect response amongst an answer choice of 4. So in answer choice A, they talk about polymers that can be formed through condensation reactions. We didn't talk about this before, but condensation reactions is another way of saying dehydration reactions. So they're the same thing. And it involves including two monomers to go ahead and join to typically make water. And that's the same thing that dehydration reaction is. So A and B are both correct. Answer choice C says all polymers are made up of multiple types of monomers. I want to point out a typical answer choice that they give students, which is the all statement. The thing with biology-based passages is you have to be wary of the answer choice all in the sense if it is a true statement. We're saying there's no exceptions to that rule, which in most science classes, that's not true. So I'm going to lean that just because of the term all, before even reading the question is kind of a red flag for me. So I'm going to continue to read the statement, which says all polymers are made up of multiple types of monomers. This statement is incorrect because polymers can be made up of a single type of monomer or multiple types of monomers. It just doesn't have to be multiple types of monomers. So if you remember, we talked about CO2 can bond with another CO2, and that is considered a polymer as well. It doesn't have to be a different type of polymer. And then for answer choice D, we have polymers are long chains of repeated units called monomers, and that's just a correct statement in of itself. So which one is incorrect? That is answer choice C. I want to draw your attention to the picture above here, which says that water is being released. This is a picture of dehydration reactions, which also is a type of condensation. Water is being released, and so it condenses or formulates. If you think of a condensation on a car window, that's when you have like water droplets that formulate, and that's condensation. So that is the release of water. So that's why answer choice A and B are correct. And D is just a factual statement, leaving us to answer choice C, which is incorrect and is the correct answer, I should say, because the statement all is very limiting and does not include monomers that are the same type that bond together. Okay, let's take a look at the following question listed here. Take a moment to pause the page, read the multiple choice question, try to make an educated guess, and unpause the video. Okay, now that you're done reading the question, let's go over some things that it says in the question. First of all, it mentions a polar covalent bond. And if you remember, we talked about a guy that is on a string. So we can say there's a tug of war. There could be like one person here who's pulling on it, and then there can be two people on the other side, and that is what determines polarity in this case. It's that tug of war, uneven sharedness between the elements. So if you see any elements in general that have the same element that are attached to each other, that's going to be nonpolar. So off the bat, A and B are incorrect. We did talk about C being a common answer choice that is polar covalent. So I'm going to put a little question mark there because I want to verify with answer choice D, and it says CH4, and C has 4 valence electrons in its shell, which means that it's going to have 4 connections, and they have hydrogens around all of those 4 connections. And the thing is, there is no lone pair. So the poles are going to cancel each other out. So there literally is no polarity on that molecule. So the correct answer choice by default would be C. And you could see here the water molecule and the lone pairs that we talked about before that show that the shape is bent, which leads us to have a polar covalent bond. I hope that you enjoyed this video. Make sure to subscribe, as I hope to make more videos like this in the future. Thank you so much, and I hope to see you back soon.
Hey, you want to know a little secret? If you hit the subscribe button, you'll be able to get up-to-date information related to AP Biology and the digital SAT math test. Making sure that you're able to understand the content is just the first step. So if you want updated additional information, make sure to click the link tree in our bio. We hope that you subscribe because each new subscriber gives us motivation to create more up-to-date content for you, students, parents, and teachers. Enjoy!